Ladies and gentlemen, as you have seen in the previous presentation, there are many non-precision approaches available in the world, and this number is increasing with our nav approaches. However, some of your pilots may still be confused about the procedure to apply to fly them. First, because they don't fly these approaches on a daily basis, and secondly, because there are several guidance modes available in the aircraft, and the pilots have to choose the good one to apply to fly this approach. The aim of this presentation is to remind you some key points to make a successful non-precision approach. You will see that flying a non-precision approach is not only a matter of approach phase, but it implies also several actions to perform on ground and in flight to prepare the approach. All the steps that should be followed to fly non-precision approaches are given in a dedicated section of the FCOM called Approach that is divided into 3 subchapters. A chapter called Approach General that provides some general guidelines and definitions. A chapter called Aircraft Configuration Management that provides the procedure to configure the aircraft for the approach to manage its energy, and this procedure is common to all approach types and all guidance modes. And we have a chapter called Aircraft Guidance Management, and in this chapter you will find the procedure to fly a dedicated guidance mode. And for each guidance mode, you can fly several approach types. In each procedure dedicated to a guidance mode, you will find the preparation of the approach on ground and in flight, the way to fly the approach, and a chapter called Management of Degraded Navigation that provides you with the conditions to abort the approach during the final descent. So my presentation is divided into 3 parts. In the first part, we will review the steps to be performed to prepare the approach on ground. In the second part, we will review the steps to prepare the approach in flight. And in the last part, we will review the procedure to follow to fly the non-precision approach, with a focus on the actions at and below minimum. So let's start with the preparation on ground. 2 steps should be followed on the ground. It is the validation of the navigation database and the check of the GPS primary availability if an approach requiring the GPS is expected at destination. Usually, this is the flight operations that perform this check. The validation of the navigation database is required to ensure that the aircraft will fly the correct trajectory if you use a managed guidance. The navigation database is considered validated if it's produced by an approved supplier compliant with regulatory requirements and or validated and approved by the operator depending on the FMS standard and on the approach type. When the NDB is validated, you can use managed guidance. And if it's not validated, you will have to use a selected guidance to fly the approach. The second step is the check of the GPS primary availability if you expect an approach requiring the GPS at destination. This check is required to ensure that the approach means will be available at destination, as you would do for any other approach. Usually, when more than 24 satellites out of the 32 are available in the constellation, you can be sure that you will have the GPS primary available at destination. You can use also a ground-based prediction tool to perform this check for you. And for RNPAR operations, for RNPAR approaches, this tool should take into account the terrain environment to make sure that the aircraft will receive the satellite signals in mountainous area. So these were the 2 steps that should be followed as preparation of the approach on the ground. Let's now review the actions to perform in flight. Most of the steps are done during the descent preparation. We will find the check of the aircraft capability with the aircraft status, the check of the flight plan versus the chart, the choice of the correct aircraft guidance mode, and the approach briefing that could include a review of the management of degraded navigation chapter. So let's assume that we will fly on our NAV-GNSS approach runway 32 left in Toulouse. If you need to remind you what is installed in your aircraft, you can refer to a new chapter in the QRH called Aircraft Configuration Summary that provides the main functions that can be used by the pilots in the aircraft. So, for example, FLS, RNPAR, or GPS. We'll check the aircraft status to know if your aircraft is capable to fly the approach. You can review also if you have open MEL items or if you have applicable OEBs to the guidance. And of course, installed equipment and the aircraft status has to be compliant with the required equipment that are given in the FCOM to fly this approach. So we assume that our aircraft is capable to fly the approach. You insert the approach in the FMS and will have to check the flight plan versus the published approach chart. This check is made to ensure that you have selected the correct approach in the FMS and that the aircraft will fly the correct trajectory with the managed guidance. You will check the waypoints, the final approach course, the altitude of the intermediate segment, and the slope of the approach. And for aircraft fitted with the FLS function, so FMS landing system function, you will check also on the PFD, the anchor point, runway 32 left, the slope of the approach, 3 degrees, and the final approach course, 323 in this case. You will check also on the navigation display that the FLS beam is aligned with the final approach leg. As we have said before, we have 3 types of minima: LPV, LNAV VNAV, and LNAV minima. As we have said before, LPV minima can be used only if the aircraft is fitted with the satellite landing system function, so SLS system, and at this time only the A350 may be fitted with this option. So we have to check to choose the guidance mode to fly this approach depending on the minima. Before doing so, let me remind you the guidance mode that you can find in the aircraft. We have 3 big families of guidance modes: lateral and vertical managed guidance, so full managed guidance, lateral managed and vertical selected, so we can call mixed guidance, and lateral and vertical selected guidance, full selected guidance. For full managed guidance, we have seen that we have the FLS function, FMS landing system function. With this function, the FMS built a virtual beam and provides to the pilot an ILS lookalike interface. It has also the very big advantage to have the temperature compensation integrated. The associated modes that you will have on the FMA are FLOC, F-glide slope, or LOC, F-glide slope, meaning that you can fly localizer-only approach with a full managed guidance using the FMS virtual beam for the vertical path. So LOC, F-glide slope mode. The FLS function is basically installed on A350 and A380 aircraft and may be installed as an option on A320 and A330 aircraft. You have also on A320, 330, 340 the well-known final APP mode that provides the advantage to be able to fly radius to fixed legs, especially for RNP AR approaches. And the equivalent mode on A350 to fly only RNP-AR approaches is the APP-DES mode. At this time, on A320 and A330, when you have the FLS function installed in the aircraft, you cannot have the final APP mode. But in the next FMS standard, you will have the coexistence final APP and FLS, providing the full benefit of final APP to be able to fly radius to fixed legs, and full benefit of the FLS function for temperature compensation and for ILS lookalike interface. Then, for mixed guidance and full selected guidance, you have on A320, 30, 40, 50, and 80 the nav FPA mode, LOC FPA mode, or track FPA mode. And for simplification purpose, we have not mentioned the guidance modes from A300 and A310, but they follow exactly the same philosophy as what is described in this slide. So we have to choose a guidance mode to fly our approach. To help you in this matter, we have in the FCOM a table called the cross-reference table that provides the aircraft guidance modes that can be used depending on the approach type that you want to fly. If we take an example of an A320 fitted with the final APP mode, we have our LNAV GNSS approach with LNAV VNAV minima or LNAV minima. We can see that we can use the final APP mode. We can use also the NAV FPA mode, but only for LNAV minima, because for LNAV VNAV minima, you need to have a vertical guidance to use this minima. And as we said, LPV minima cannot be used. We always recommend the use of a full managed guidance to fly non-precision approaches. So for aircraft fitted with final APP mode, the final APP is the recommended guidance mode for the approach. On the example of A320 fitted with the FLS function, we have the LNAV GNSS with LNAV VNAV minima and LNAV minima. We can use FLOC F-glide slope mode for both minima or NAV FPA mode. But LNAV VNAV minima cannot be used with NAV FPA. LPV minima cannot be used neither because A320 are not fitted with the satellite landing system function. In the same way as final APP, we recommend the use of the FLS function to take full advantage of the ILS lookalike interface and the temperature compensation. So we have checked that our aircraft is capable to fly the approach. We have checked the flight plan versus the published approach chart. We have chosen the correct guidance mode to fly the approach. We can now perform the briefing. You have an example of the briefing in DFCTM, and you can we will recall the strategy of the approach, flight plan, minima, the choice of the guidance mode, and anything which is specific to this approach. But in addition to this briefing, you can add also a reminder of the conditions that could make you abort the approach during the final descent. And these conditions are described in the chapters Management of Degraded Navigation. So our approach is prepared. We can start the descent. And during the descent, we will confirm the strategy for the approach with the check of the navigation accuracy. On an A320 fitted with final APP mode, the check of navigation accuracy will be done on the probe page. If you have the GPS primary available, it means that you can fly your approach requiring the GPS, and you can use the final APP mode. If you have GPS primary lost, but the navigation accuracy is still high, you cannot fly an approach requiring GPS, but you can use the final APP mode with raw data. And if you have low accuracy, it means that you cannot fly an approach requiring GPS and you cannot use the final APP mode. You will have to revert to a full selected guidance in this case. On A320 fitted with FLS function, this check will be performed with the FLS capability. You will press on the LS push button passing 10,000 feet to display the FLS capability. When FAPP is displayed, you can fly GPS approach, and you can use FLOC F-glide slope mode. If you have FAPP plus RO, you cannot fly an approach requiring the GPS. You will have to revert to another approach. But you can still use the FLOC F-glide slope mode with the confirmation of RO data. If you have RO only, the FLS must not be used at all. So no approach requiring the GPS, and you cannot use FLOC F-glide slope mode. So we'll have to use a full selected guidance. So we have reviewed the steps to prepare the approach on ground and in flight. Let's now focus on the procedure to fly the approach. We will go to the initial, intermediate, and final segment, and with a focus on the actions at and below minimum. We will consider the use of full managed guidance mode, final APP or FLOC F-glide slope, as they are the recommended guidance modes. You will arm the approach mode when cleared for approach. For final APP, an additional condition has been recently introduced. The approach should be armed when the two-way point is the final descent point. The purpose is to avoid cases where the final APP mode flies level of segments. It is not designed for that. Once you have armed the approach by pressing the approach push button, you have to check that the appropriate guidance modes are armed. So, final blue, APP nav blue, or F-glide slope blue, FLOC blue. Once reaching the intermediate segment, you have to ensure that the appropriate guidance modes are engaged, APP nav, FLOC. You continue on the intermediate segment, and you identify the position of the final approach fix with the call-out passing FAF at the given altitude, and you check that the vertical modes are engaged, final APP, F-glide slope. During the final descent, you have to monitor and adjust the flight parameters, so cross-track or VDEV for aircraft with the final APP, with the altitude versus distance monitoring, or the deviation of the FLS. During this final descent, you have to keep in mind the conditions that should make you abort the approach, and that are defined in the management of degraded navigation chapters. At minimum, the pilots have to take a decision, continue or go around. If you have visual, as explained by Xavier, you can continue the approach. But if at any time during the final descent you lose visual references, you have to go around. So respect the minimum, and if visual references are lost, go around. As a conclusion of this presentation, we have seen that flying a non-precision approach is not only a matter of approach phase, but it implies several actions to perform on ground and in flight to prepare the approach. On ground, we have the validation of the NDB to ensure that the aircraft will fly the correct trajectory in managed mode. We have the check of the GPS primary availability to ensure that the approach means is available if you want to fly on an nav GNSS approach, for example. During the descent preparation, we check the aircraft status to check that the aircraft is capable to fly the approach. We have checked the flight plan versus the chart to check that we have select the correct approach in the FMS. We have chosen the correct aircraft guidance mode with a recommendation to use full managed guidance to fly non-precision approach. We have performed the approach briefing, taking into account the conditions to abort the approach during the final leg. During the descent, we confirmed the strategy of the approach with the check of the navigation accuracy. And during the approach, we engage the appropriate arm and engage the appropriate mode, and at and below minima, do not forget to have visual, and if you lose visual below minima, you have to go around. Thank you.